Hello, this is Mr. Win, and this video is about solving polynomial equations of degree 3 or higher. So first, remember that the degree of a polynomial, that is the highest exponent on a variable, is also the number or amount of roots of solutions the problem will have. This number includes real roots, imaginary roots, and even double roots, triple roots, or roots with multiplicity. We will talk about that later. For example, all linear equations always have one real root. They always cross the x-axis, have an x-intercept. All quadratic equations have two roots. Now these roots might be two x-intercepts, like two real roots, or maybe two imaginary roots, or maybe one root where it touches the x-intercept once, where it's a double root because it's repeated. Then all cubic equations always have three roots. Could be all three, or it could be real, or maybe one real and two imaginary. Remember, imaginary do come in pairs. Also remember that the best way of solving a complicated or difficult equation is to factor it and then use the zero product property. So take this problem for example: 2x to the fourth plus 13x cubed minus 6x squared minus 3x plus 54 equals 0. That problem is really hard. I couldn't instantly do it. It looks extremely hard in that form. But once they give it to us in factored form, right there, it's easy. It only takes us a few seconds. We know this is a multiplication problem that equals 0. So one of these factors must equal 0. So set each factor equal to 0. So I'll write them all in red. And then solve them. Remember, factoring makes these problems basically algebra 1 linear equations. For the first one, you just subtract 3, you get negative 3. Second one, you add 3, divide by 2, you get positive 3 over 2. Third one, you subtract 6. Fourth one, you add 1. Those are our four answers, because this is a quartic equation, degree 4 equation. You could write your answer like this. You're supposed to put in order from least to greatest, but I'm not too worried about that. By the way, if you don't write that step in red, if you can start from this step, the factory step, and go straight to the answers, that is perfectly fine. Usually I skip that red step and do it in my head. All right. So here's the graph. Keep in mind we just found the roots, x-intercept solutions, zeros to that function y equals all of that. Remember, it's called a zero because y is 0. If you look at these points, here's 0 for y, here's 0 for y, here's 0 for y, here's 0 for y. All right, so basically we just did 0 equals all of that thing. All right, so here's the bad part. We have an issue. There is no simple way to factor equations of degree 3 or higher. If it's quadratic, you know how to do guess and check, difference squares, all that easy stuff. All right, if it's 3 or higher, it is pretty much humanly impossible to do so instantly. If you know a way to do it, tell somebody, you'll get rich. That's going to be a big discovery for math. All right, but there is a way to do it, but it's just not simple. It's complicated or long. The only thing we can do is recognize a specific fact and then guess and check as many times as it takes to find one factor at a time. So it's pretty slow. That fact is called the rational root theorem. You should learn that in Algebra 2. Here's what it says. If, in the big words, if there are any rational roots as solutions, rational means it has to be a whole number integer or fraction. That number must be in the list of plus or minus p over q. P must be a factor of the constant term, the last term, and q is a factor of the leading coefficient. All right, so this list doesn't guarantee an answer. It only guarantees if it's rational. If the answers are imaginary or irrational, it is not going to be in this list. So there are times where this list is absolutely nothing when you're unlucky. All right, so be sure to put the polynomial in standard form, where the term with the highest degree or exponent on the variable goes first, and it goes down in descending order until the constant where the no variable goes last. So you all know you have x squared first, then x, then no x, right? Or x to the fifth power, then x to the fourth power, then x to the third power, x to the second power, x to the first, and 0, x to 0. All right, so let's try it on this fourth degree polynomial we just solved using the calculator. So notice our p is 54. That's the last term. And our q is 2. We have to figure out what are the factors of 54. What times what's 54? So we have 1 times 54, 2 times 727, 3 times 18, 6 times 9. Those are all the factors. Don't even worry about the signs. Like say this was the negative 54, don't worry about it. The plus or minus takes care of itself. All right, for q, there's only two options. 2, this is 1 times 2. We now have to make a list of all the possible p's over q's. So I always do the first p over all the q's, and the second p over all the q's, and the third p over all the q's. It's pretty long. So it's going to be plus or minus. I'm not going to write the plus one each time. The first p over all the q's, so the 1 over 1, and then 1 over 2. Then the next p, 2 over 1, 2 over 2. Then the next p, 3 over 1, 3 over 2. Next p, 6 over 1, 6 over 2. Next p, 9 over 1, 9 over 2. And I'm going to keep doing this, and I'll finish the rest, and that gives us the whole list. Now, we need to simplify the list. We got to reduce if we can and take out any repeats. So I'm going to go in order. The first one is plus 1 over 1. That reduces to positive 1. The next one's plus, 1 over 2. That's new to our list. So I'm going to need 1/2. Then 2 over 1 is new. That's just 2. And then 2 divided 2, well, that reduces to 1. We had on the list, so that's a repeat. I skipped that. 3 over 1 is 3. 3 over 2 is new. 6 over 1 is new. 6 divided 2, that's 3. 3 is on our list, so that's a repeat. All right, 9 over 1 is new. 9 over 2 is new. 18 over 1 is new. 18 over 2 is 9. That's old. That's a repeat. 27 over 1 is new. 27 over 2 is new. 54 over 1 is new. 54 over 2, that's 27. That's a repeat. So there are actually 4 repeats on this list. So that giant list I have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 things to check, but the positive and negative versus there's actually 24 numbers to check in our list. Now remember, we solved it. These are the actual answers again. Are those numbers in my list? Is negative 6 in here? Yeah, negative 6 is part of this number. Is negative 3 in there? Yes. Is positive 1 in there? Yeah. Is 3 over 2 in there? Yes, right here. See, all 4 of the answers were in this list because they're all rational. All right, so now you found the list. Once you have your list of possibilities, you start using them one at a time in synthetic division. You might have to remind yourself if I do that, like Google it or ask me for the live session. And I'll do the process now in a second. But you're basically guessing to see which one of those will give us a remainder of 0. If that happens, that means we found a root, an answer, an x-intercept, a solution. But if it doesn't happen, you just try the next guess. Remember, when doing synthetic division, you must create the chart correctly. You must put zeros in the place of missing terms if there are any. And the number of terms is always equal to the highest degree plus 1. So now I'll demonstrate the process using this. So I'm going to try going on. I'll do positive 1, then positive 2, then positive 3. I'll try them positives first. I'm just guessing. You can guess in any order you want. You should get lucky. All right, so we're going to make the chart. Remember, the guess goes here, the possible root. Then you have to write all of the terms that we're dividing. The degree is 4. I mean, that one has 5. Actually, 5 numbers. Next to x to the 4th power is positive 2. Next to x to the 3rd power is 13. Next to x squared is negative 6. Next to x is negative 63. And the constant is 54. So there's 5 numbers there. All right. And then I'll do this. Draw a line. Remember, for synthetic division, you drop the first number. Then you multiply that number, whatever's in the box. So 2 times 1 is 2. Then you add downwards. That's 15. Multiply the number in the box. That's 15. Add down. That's 9. Multiply. Add. Multiply. Add 0. This is the end of the remainder of 0. That's good. That means 1 is our answer. So we know x equals 1 for sure. All right, I'm going to now try the next thing. So let me move this down. I'm going to erase it. All right, so positive 1 is good. Let's try positive 2. If I try positive 2, put a blue 2 here. Again, drop the first number. Multiply, add, multiply, add, multiply, add, multiply, add. That's 40. 40 is not our remainder of 0, so that's bad. So 2 is not an answer. So I'm going to try something else. Let's try positive 3. So again, I'm just going down this list until I find all 4. It gets pretty long. So drop, multiply, add, multiply, that is 57. Add, multiply, add, multiply, add. Definitely not 0, so 3 doesn't work. All right, so maybe let me try some negative numbers. So you can go any order you want. You can try negative 1, negative 2. I'm actually going to try negative 3. So let's see if that works or not. Put negative 3 in here. Drop, multiply, add, multiply, add, multiply, what's that, 60, 81. Add, that's 18, multiply negative 4, add 0. Look, you got 0, that's good. So we got another answer, negative 3. We keep going, but I'm going to pause there. Look, we found 2 of the 4 answers already, 1 and negative 3. But doing the same process to find the last 2 is going to be very tedious. It may not even get us the final answers because the last 2 could be imaginary or even irrational. Because of that, we should, what we have and should use an additional technique that is called depressing a polynomial. It says once you find or know an answer, you can simplify the problem, make it easier, by just using the new equation that came from synthetic division. From there, you could redo the rational root theorem list, and you actually get a smarter list, or just keep using the original list and keep going from guesses. But the synthetic division will be much easier because the numbers are smaller and there's less to go through. Now, you'd ideally do this process until you end up with a quadratic. Once you have a quadratic, you factor like normal because those are easy. Just do guess and check, do different squares. Now, if you can't factor it, if it's unfactorable, do quadratic formula because that's for irrational answers or even imaginary answers. And just so y'all know, it is possible to solve quadratics using this rational root theorem and synthetic division process, but that's overkill, and I would not do that. So I will now do the entire process using depression. So remember, the first part is actually find the list, so percent already did that. Then I'm going to try putting, let's do 3 first, or negative 3 first, because that was an answer, right? You can go in any order you want. So the original was 2, 13, negative 6, negative 63, 54. I'm going to do the process. So remember, it was drop, multiply, add, multiply, add, multiply, add, multiply, add. Remember, this new equation is depressed. The exponent went down one. So this 2 goes to x to the 3rd power. This positive 7 goes to x to the 2nd power. This negative 27 goes to x. And this positive 18 is our constant. So that new equation, I'm going to do synthetic division again using the next guess. So we knew the answer was 1. So I'll do that here. So this one has degree 3. Add one has 4. There are 4 numbers. Yes, it was 2, 7, negative 27, 18. I'm going to do synthetic division again. It should be 0 because we knew 1 was an answer. We're making the problem easier. So add, multiply, add, multiply, add. So this new thing is our new equation, 2x squared plus 9x minus 18. We could do more synthetic division, but no need. It's quadratic. If it's quadratic, you should know how to factor that instantly. So over here, let me write it. All right, so they're GCF? No. Let's do a guess and check. I'll use ice green. So the only guess for 2x squared is 2x and x. And for 18, let's do, I guess, 3 and 6. My outside is 12x, my inside is 3x. Can 12 and 3 make 9? Answer is yes. I need a positive 9, so the 12 is positive, and the 3 is negative, and then a negative times a positive is negative. We're good. We now set those equal to 0. So this first one, we're actually going to just go straight to the step. You add 3, divide by 2. The second one, you just subtract 6. We found our 4 answers. So we have, here's our first one, second one, third one, and fourth one. All right. So that's the full process. All right, so it's kind of long, but it's not too bad once you get the hang of it. And I'll give you all some more easy numbers. But we will practice this. Make sure you join live sessions or watch the recordings, so I will do a bunch of these, even some harder ones. All right, last slide. Sometimes you have to do the reverse, which is actually a lot easier. If you're given the roots or solutions and are told to find the equation, just change the roots into factors and multiply them together. Keep in mind that the imaginary solutions always come in conjugate pairs. So if you're given one of them, you must add its conjugate to the list because that is hidden in the list. So there's 2 little problems here. It says write the minimum degree polynomial that has those roots. First one has the roots of -2, positive 5, and 7 over 4. Remember, to change the root to a factor, just change the sign and put next to x. So -2 turns to a positive 2 next to x. That positive 5 turns to a -5 next to x, and that positive fraction turns to a negative fraction next to x. Remember, you also have to fix the fractions. The denominator goes to the front. It's always a positive number. So this stays x plus 2. This stays x minus 5. And this last one, the 4 goes to the front, x minus 7. This is an equation. Now, it just said write the equation. I did write the equation. I wrote the equation in factored form. If it asks you to write the equation in standard form, you actually have to multiply that out. You have to FOIL, combine terms, and do that FOIL or triple distribute again, which gets kind of long. All right, one more. Find the equation, minimum degree, with the root 6, -3, and 5 plus 2i. They're trying to trick us here. They have an I thing there. We need its conjugate. So the conjugate would be 5 minus 2i. All right, then like before, I'm going to write the 4 factors. Just change the sign, put next x. So it's going to be x minus 6, x plus 3. Now be careful here. You have to do x minus, because that's a positive. So it's always subtracting the thing. So when you subtract 6, it's minus 6 right here. But when you subtract -3, it makes it plus 3. So that's what that means. So I have to minus this thing. I need to put parentheses around this. This will be 5 plus 2i. And then the other one will be x minus this thing, 5 minus 2i. Well, notice you have to distribute for those. So this stays the same. This stays the same. When I distribute the -1 here, I get x minus 5 minus 2i. There's this one. Then I subtract I distribute the -1 here, I get -5 plus 2i. All right. And that is our equation in factored form. Again, not standard form, factored form. If they ask you standard form, you have to multiply it out. And that's it. If you have any questions, make sure you ask in the live session or in class. Thanks for watching. See you soon. Bye.